Okay, good morning everyone. Apologies, my presentation will be in English. I'll try and keep as slow as possible for the translator. My name is Mick Hodgson. I'm Technical Manager for Tekla Trimble in Finland, and I'm here today to give you a presentation of Tekla Structures. I like to show everything as live as I possibly can, so today's presentation we're going to be focusing, of course, looking at the software and how you can use the software to achieve productivity gains and to make your life easier, really. So when we take a look at this software in detail, I'll explain how we can build a model from nothing, or how we can use integrate with AutoCAD to create this kind of structures that you're looking for. Before I do that, I'll just start with a quick PowerPoint. I'm not going to spend too much time on this, but it just sort of allowed me to start what I'm talking about. So Tekla is a specialized modeling software for steel and concrete construction. Excuse me. It differs from AutoCAD because what we're doing is we're building a one-to-one scale model, and then from that model it creates everything you need for fabrication: drawings, material lists, CNC data, etc. So like on AutoCAD, where you do a drawing with lines, work out the material, that's all fully automatic from the system. And you'll see that as we go through. We're involved in all kinds of structures. We're involved in everything around the world, really, from oil and gas projects, bridge work, offshore platforms, even specialized sculptures, that kind of thing. In my Tekla world, this is an example of my Tekla world. You can see again the examples of structures we're involved with, such as offshore platforms, wind turbines, general structures, bridges, even transmission towers. So really anything that's done in steel or concrete construction can be done within Tekla. So a few examples: football stadiums. All the football stadiums for the recent Brazil World Cup are on Tekla, every single one of them. Bridge work, we do all kinds of bridges, from regular highway bridges through to architectural style bridges. So any kind of bridge work. So that's complex, twisted, curved elements. Transmission towers. Is anyone involved in transmission towers? It's a very, very complicated. It looks very simple, but they're actually very, very complicated structures. Very complex 3D geometry. So those can be done in Tekla as well. And again, offshore. We have a lot of offshore companies who use Tekla for typical platforms, wind turbines, even floating production systems. And again, an example of wind turbine. These are actual projects, by the way. And we're also architectural projects, just a few examples of these. You can see here the Sky Park in Singapore, so architectural type buildings. Again, another architectural type museum. And this is my favorite, actually. This is the super tree structures. It would be almost impossible to detail that manually, to try and work out the mathematics of the length of pieces and the connections and things. In Tekla, what you're doing is just building a model, then everything's created from it. So, nice, easy way of working. I'm going to skip through these slides. What we can do as well is when you're working within Tekla, you can share the model in the cloud. So anyone around the world can access and work on the model at the same time. So if I've got an office here in Belarus, I can share it with my fabrication plant that's in another part of the country, or even share it to a company that's working in Russia or America or wherever. So, but only the people with permission can access that model. So you own the model, but you share it to the people around the world, so they can access the model at the same time. We can interface to all the standard softwares that you might be using as well. So for example, I'm sure you'll recognize these formats. We can take in DWG, DXF, this is typical stuff, but link to STAD Pro, Robot, SAP 2000, all the standard softwares that you use in our industry, we can interface to as well. Again, examples, so we're involved in structural, bridge work, miscellaneous work offshore, plate work, metal frame, transmission towers. Again, just going through a few examples. But what do we create when we actually build the model? What's the purpose of building the model? Well, of course, what we get from the model is all the material lists. So these are all automatically generated. So Excel spreadsheets, barcodes. I'll slow down for the translator, actually, just in case I'm going a little bit too fast. So barcodes, painting lists, and then all the manufacturing data, such as individual drawings with weld preparations, layout for bolts, so on and so forth. So any kind of drawing you want can be created. And of course, what we're doing from those drawings then are creating the elements themselves, or the parts. And again, you section through plans, elevations. So these examples here are not drawn manually. Let's find out where the actual pointer is. Ah, there we are. So these here are not drawn manually. They're actually created automatically from the model. And again, for creating full and complete construction. Then from that, we can then link down to automated workshop machinery, such as these machines then take the data from the model and automatically cut and manufacture the elements, cut the pieces. What we do with Tekla is then we take the software, we extract out the data and we pass it down to software such as Steel Projects. And then Steel Projects takes this, does the management of the workshop. So it does the CNC control, but also it does the nesting for bars, which Anestis talked about earlier. So nesting of elements for parts, for plates. And also it does a time calculation. So you can take the model from Tekla, then the software will tell you how long it's going to take to manufacture that project in your factory. I'm not going to talk too much about this because my colleagues here will be taking that further. Okay, so basically what we're doing then is from the model we're taking it down to the workshop and passing it through the workshop. Right, let me just make some room here so I can do this live. Hopefully you can still hear me. So this is a Tekla model. You can see here what we're doing is building a model. It's full and complete. Everything in Tekla is an object. So you can see there we've got a plate with a weld. If I click on that plate, you can see 10mm thick. What I'll do is I'll say let's make that 30mm thick. And you can see the thickness changes on screen. Okay, that means the drawing is updated, the material list is updated. All I'm doing is creating the model. You can see there we have a weld. If I click on the weld, you can see it's a 6mm weld. I can say let's make that something stupid like 20mm. So you can see then, click on the weld. Let's just modify this one here, make that 20 as well. This is for both sides. And if you modify that, you can see the weld changes on screen as well. So you get the weld volumes, weld areas, everything. So let's just take that back, like so. The bolts themselves, the bolts. Click on the bolts, you can see the bolts are 30 diameter. You can make those bolts any diameter you wish. And the bolts are automatically calculated as well. You can make those bolts, let's say, countersunk bolts, which are special kinds of bolts. Let's make these 20, so you can see now they're countersunk bolts. So it's very easy to modify what's already there. If I want to put a new piece of steel in here, let me just make sure I've got this set up right. I have. So we'll say, let's draw a steel beam. He says, okay, what's the size of the beam you're going to put in there? Then you have the full worldwide library of standard parts, Russian, Japanese, American. So pick up the size you want. So if I say, well, look, it's going to be a UB, universal beam. Let's say it's a 406. These UK sizes, by the way, I apologize. Then what we can say is we say, okay, let's draw that piece from the nearest point of that column, and we'll take it perpendicular to this column here. So drawn in a piece of steel like so. Okay? Then how is that connected? How is that beam connected to the column? Then we have a range of connections. So you can see here we've got beam-to-beam connections, like so. All the different styles with thousands of these connections. So you choose the type of connection you're looking for. In this case, I'll use 101, which is just a typical UK connection, end plate 101. And what we'll say is we'll say connect that column to that beam. It looks at the two of them and then creates the connection. So if I just zoom in there, you can see that it's created the connection with the bolts the other side. The connection is created. I can click on that connection and I can modify it. So I can say, okay, look, the end plate goes to the top of the beam. So now you can see, if we just click on that, let me do it properly. Type in there 0. So you can see now the plate goes to the top of the beam. I can say it also goes all the way down to the bottom. So now it's full depth. I can say how many bolts. I'll say, well, I just want to have 3 rows of bolts in there. So it'll alter the number of bolts. And then the spacing, so let's say this bolt spacing is 100. 100. So you can see you can alter the spacing of the bolt. So you set the connection up exactly as you want it. So if we come to the other side, same connection. We do it properly. That one connects to that one. You can see then it looks at the two. I knew I'd done that the wrong way around. That one connects to that one. There we are. If you choose it wrong, it connects to the other one. So you can see then that's the connection there. And again, it says I've determined it. Right, then we can say give me a drawing of that piece. And that's it. So I create the model. Everything else is automatic. So we can click on this one here. We go to drawings. And then within here, you've got a library of standard drawing output. So if I say here, let it just load up. So let's go to here. And we'll say for assembly drawings. Go to all actually. Bear with me. Oh, there we are. I'm just going out of here. So let's go to this one. Just expand this out. We'll go to assembly details. These are like drawings of, well, what kind of drawing do you want? So we'll say here, look, I want to create, let's say, style one with parts. You say create drawings. What it does first of all is it actually numbers the project. So it does the numbering of the project. Then it automatically creates the drawing. So once that's finished, it's now creating the drawing. That's it, fully detailed for me. Just give that a second. You can see then creating the drawing. The first one takes a little time, the others then are full and complete from there. Let's just run that through. There we are, so that's finished. We then go to the drawing list, like so. You can see there's the drawing list. Show me the one I just created. There it is, and if you click on here, you can then see the drawing on screen. There it is, look. Let's just make that bold. You can see that's the drawing of the plate with the spacings. That's the detail of the beam. And you can see there, look, you've got the material list, the size, the grade, the length, everything automatically created. As well as the drawing of just the beam itself, if I go to the drawing list, we can also have, let's say, the sections and plans and elevations. So again, if you take a look, open up this drawing. Bear with me, you can see then that's the sections and then plans. That again, that's automatically drawn and automatically updated with all details as required. Again, go back to the drawing list. Just close that one down. Oops. Just go out there. Go to the drawing list. Let's say then, let's take a look at a regular kind of detail. Let's create this one here. Open this drawing up. So these are then complete and full detailed drawings. Just open that so you can see here a real drawing fully detailed. That's more complete, looks. That's all the details there of all the pieces. Like so. Okay, so as well as all the detailed drawings, part drawings, everything, we also get the material lists. So if we go to the reports, I'll say open these with Rec Viewer. Then we'll say, okay, give me a material list for that structure. And if we show this on screen, you can see then it creates an Excel spreadsheet. And that's an Excel spreadsheet of all the data from that model automatically generated. Okay, again, full and complete. We can also create any kind of material list you want, welds, bolts, anything. But if I say, let me create a barcode, let's just show this on screen. So that's a barcode of every piece in the model as well. So any kind of report you want is generated from the model. Okay, so they're all available there. Then, of course, if we're taking it down to a CNC machine, what we can say is we can click on the parts. So let's see here. We can go. we can say export that out to a CNC machine, and then we can take out these pieces here like so, add some specialized stuff and say, okay, create the data to go down to the machine. Again, it numbers that. And then we create the data then to go directly down to the CNC machines. So nice, easy, quick way of doing it. And it's all one click. So as a detailer, all I'm doing is I'm just creating a model. And then from that model, everything's automatically generated for me. So nice and simple stuff. Okay, with me so far? Yeah, good. Okay, just let this one run through. I just go into that model. Just let that run through actually. So if we go here, go to this one. So if we go to Tekla Structures models, the one I'm working on here, just bear with me. Let's find the model I'm looking at. That seems to be, let me just close this down. Seems to just be hanging there for a moment, so I'll just wait for that one to complete. Let me just end that. Sorry? Yeah, I'm going to do. Let me just restart that. Let's just cancel this. Sorry, guys. Because I'm running on the screen, it's just taking a little while. That was good, wasn't it? Yeah, I don't know. Bear with me. Fun stuff. There we are, finally. Okay, so just start Tekla, it's no big deal anyway. So here we are, so we're working in UK, let's start this up. So what I'm going to do then, I'm going to actually create a model from the start. So I'll create a new model. So now, what happens, that was a model, existing model. But how do I start from nothing? So I want to create a model, a brand new model. So what I'm going to do is I'll create a new model. Yes, exactly. So you've got AutoCAD drawings. Let's take those into Tekla and do a little work on them. So what I'm going to do is create a new model. And again, this is like creating an empty drawing in AutoCAD. Start that up. Do you know what? I've never had a problem. And the first time I come here, I've got a problem with this. I don't know why. It seems to be, for some reason, being delayed. You know, I'm meant to reboot my computer here. Oh no, I think it's coming. There we are. Finally, we're into it. Sorry, I'm being too vague. There we are. Back to normal. Here we are. Sorry about that. Okay, so what we got then, we're into Tekla, we've created a new model, and as you can see, it's empty. We're working that typical XYZ coordinate system, just like AutoCAD, so you can see there XYZ. You can pan left to right with the mouse, you can zoom in and out, you can spin around in 3D. It's nice and easy. What we do first of all then is we set up the grid lines. These are the grid lines here, you can see them. There they are. So what we do first of all is we set those up to suit the project. So if I look in plan view, and we double click on the grid lines, I'll say, okay, in the X direction, we've got, let's say, 3 meters, let's say 5 bays at 7,500, and we've got 3 meters. So that's my basic spacing. Then here, I've got 3 meters, let's say 3 bays at 7,500, and 3 meters, like so. And then, what's the elevations of the buildings? We've got 0, 425, 4,500, 8,500, and 10 meters, like so. And then what's the name of the grid lines? You'll see in a moment what this is. E, F, G, H, and 1, 2, 3, let's say 4, 5, 6, 7. And then in the Z direction, what's the name of the elevations? So what we're doing there is putting X, Y, Z. So let's put here then, we've got base, we've got finished floor, first, eaves, let's say apex, like so. So then if you modify the grid lines, you can see that's the grid layout of the building we're going to create, like so. So just pick it up. Then, of course, you can pick up individual grid lines, such as this one, because buildings are not standard. So you can pick up then this grid line here, and we can say, okay, copy, rotate, and we'll say I want to copy this grid line here, and let's say I want to have 5 copies through 25 degrees, copy that, so you can have any kind of grid layout that you want, like so. So it's just like AutoCAD style commands to do that. But I'm happy with the grid lines there. Then what we do is create a window on every plan and every elevation. It's automatic. So if we then say create view along the grid lines, I've now got a view looking on every elevation and every plan. So for example, grid line A, if I click on here, you can see that's an elevation looking directly on grid line A. So I can then say, okay, let's draw a beam in here. So let's draw a beam from this point to this point. And I'm drawing a beam directly in that view, but it's creating the 3D model behind it. So nice. You can work in 2D, you can work in 3D. I always work in 3D. So let me just undo that, come from there. Even though there's nothing in that model, I can still create a drawing. So I can go to my drawings, and I can say, okay, let's have a catalog here, and then what I'm going to do is I'm going to say let's create a plan on the base of the building. So we'll say create me a plan view, create drawings, and then it says which view do you want to view on. So I'll say I want a plan on base, open that up, and that's a plan looking directly on the base of that building, like so. There it is. I can click on this and I can change the scale of it. Let's say make this 1 to 75, like so, and arrange those drawings. Okay, that's it. It's an empty drawing. As I build the model, the drawing automatically updates itself. If I go into here now and let's say put in some concrete bases. So let's put in some concrete elements because I'm going to do steel and concrete. So let me put let's say concrete pad, and let's say I'll put it in at this point here, like so, and that's a concrete pad. You can see there it is, look. And if you click on this pad here, we can change the depth of that just by dragging it up. So you can make that any size you want. Just drag it out. That's the size of concrete, look. And that's how you alter the concrete. Let's take that back. Or we can type it in physically. So I'm going to say it's at 0 elevation to minus 500. And let's modify that. So that's a concrete base in there, like so. If I go back to my drawings, you can see then the drawing has updated itself to have the pieces of concrete in there. So the drawing just redraws itself, basically. And I can go to that and say, okay, let's add some dimensions. So a dimension from here to here, like so. 1500, and a detail from here to here, like so. 1500. And then I can continue working on the model. So let's get back out of there. Let's then pick this one up, and we can say, okay, let's copy that. And we just copy it around the building. So once you've got one piece in there, just pick it up and copy it. And let's put this one here as well, like this. So, simple way of working. If then this piece changes, let's say it's become a different size, let's say it's now 200 millimeters bigger, either way, if you go back into your drawing, you'll see the drawing then has updated itself, but it's also revised those dimensions. So it does automatic revision control as well. Right, so what I'm doing there is I'm just working away as usual. But let's say I've been given an AutoCAD drawing. Okay, somebody's working AutoCAD. I can bring that AutoCAD drawing into Tekla. So let's click on here. Let's say add a model. So this means bring in a model from AutoCAD or a drawing from AutoCAD. Let's browse. D drive actually. My custom. I've got a few examples here that I've been given by different clients. So if I bring in, let's say, this DWG here, and if we add that into there, you can then see that's the AutoCAD drawing brought into Tekla, like so. Let me just click on there so you can see then. Yeah, there we are. You can see that's brought in. And then what we can do is we can click around this drawing, and we can say, I've got a special snap here, and I can say, okay, let's turn, let's say this piece here. Just click on this so I can pick it up properly. Click on that, you can change it into a beam. So you can click on the lines and change them into beams, like so. So again, you can quickly click on the AutoCAD drawing and modify it, like so. So that way you're reusing your AutoCAD drawing and just drawing over the top of it, and by clicking on the elements and changing them into real pieces. If I go back into the drawing, which is the GA drawing, like so, you can see then that drawing itself, that's the pieces I've just added. But in my drawing, I can also turn on the AutoCAD drawing. So just click on here, I can then go and I can say, okay, reference objects, there we are. just turn this on. We can say turn that on in here, so visible. So that is my AutoCAD drawing in my Tekla drawing. So you can have the two together. So you can double check one over the other. So you see how that works. You can either build it from scratch, from nothing, or you can start from an AutoCAD drawing, or you can bring in an analysis model. It doesn't matter to us. Right, so let's just continue a little bit further. Let's draw in a steel column. So now I'll draw in a steel column. I'll put the steel column here like so. So you can see that's a steel column in that project. Let me just take that off because I'm going to actually put that on the grid line layout like so. These pieces can be anything, so if you click on here, it can be any size, but we can also put it any position, so you can rotate that through 90 degrees, do what you want with it. So let's say this is at, let's say, 0, enter that, it's now that way around. Again, you've got what's the length of that, so you can see there's the length, 7450, but I can click on this and say, look, actually, I want it to be just be 5 meters tall, and it'll change the length of that. And then we can say, okay. Let's put a connection on there, so we'll have a base plate. So again, you've got your base plate, standard bases. And we'll put the base plate on the base of that column. And again, it looks at the column, looks at the piece, and then creates the connection accordingly. You can see there with the welds and everything. Yeah? We can say, okay, this is, let's get, got a splice. It's a splice connection, so we can say, okay, edit. I want to split this about the middle. Pick that up like so. So now there's two pieces there, you can see them. And then what I'm going to do is I'm put on there a splice connection. So let's just say a regular column splice, this one connects to this one, and that's then spliced like so. Again, any of these connections, you can click on them and change them to the kind of connection you want. Right, and then once you've got that, we can pick these pieces up, and again, we can copy those around. So let me just show I've got that turned off, and we can say then, okay, let's copy this from there and put it over there. Let's put it to this one here. Let's put it to this one here. And remember, everything you're doing on here, drawings are always updating themselves. So now look, you can see, look, we've got the data on there as well. You can click on any of these. It's just an object and say, what's the mark of that? What's the size? And it's just a drawing. You can do what you want with the drawing. You can even take that drawing into AutoCAD if you wanted to. Okay, is that clear so far? Yeah, quite straightforward actually. In fact, to be honest, if you've used AutoCAD, or your background's AutoCAD, it's quite straightforward, especially if you've used 3D AutoCAD, really the principles are almost identical. Okay, let's close that down. Let me just continue with a little bit more detailing on this then. So let's say I'm now going to draw a steel beam, and the beam goes from the end of that column there, just turn that snap off, to the end of that column. So I've added a beam in there now. And then I'll say, okay, use connection 103, which again is a typical UK connection. That connects to that. And that is a shear tab connection like so. Come along to here. That one connects to that one. And then what we'll do, this time I'm going to weld those two. I'm going to actually split this. So I'll say, okay, let's edit, split this. So it's two pieces like so. And then I'm going to weld these two together. So now I'll say steel, a weld in there. It's what we call a polygon weld. That one welds to that one, and the weld goes from that part there to that point there. That's a typical little weld. I'm going to click on that, and then I'm going to say, okay, that weld is, let's say, 8 millimeters, and then you've got all the different types and styles of welds on there. So we'll say, okay, it's a fillet weld. It's 90-degree angle. And let's say it's got a 2 millimeter gap all the way through, so 2 millimeters as well. And if you modify that, you can see then that's the weld in there. And then we can say, okay, do the automatic preparation of that. That beam is cut, the weld preparation is automatic to those pieces like so. And that's how you can put really any element in there. So it's quite straightforward. But then of course we can say, right, look, I want to have now drawings of these pieces. So window those. Go to the drawing production, different styles you can choose from. So I'll use style 3, which is a recommended one. You can click on here, create drawings, number it, and again, if it goes away, it numbers that and creates all the drawings you wanted for that model. Again, the first time it creates this, it takes a little while to do it, but then the rest of the time it's pretty quick from that point. So let's just create those. and then we'll move on from that. Then again, of course, what we do is we can actually then download this information straight to the CNC machines and steel projects. So again, now it's creating the drawings of all those pieces. Not just the fabrication drawings, but drawings of every small element as well. So let's run this through and we can see those. Okay, so it's created all those drawings. So now if I go to my drawing list, your main GA drawing, then beneath that we've got the details for all the pieces. You can see there, that's the one I just did with the automatic weld preparation look. You can see that's the information I typed in, 2mm gap, 8 and 6. And that's the details of the pieces, look. Okay, let's go to the next drawing. So you can see that's the detail of the column, look. So you can see there the column. I'm showing there, if you just take a look through. There, the sort of root radius, fully detailed. Again, what the diameter is. If I look at the top, you can see there's a full material list, size, grade, length, total surface area, total weight. Next one, that's the top of the splice. Then the detail of the beam look like so. So really easy and straightforward. What I'll finish this little one with, I'll just say, go back to that model, because it's now time for a coffee break. But what I'll do here is I'll say, okay, let me create a final drawing. So create drawings, again with the catalogue. I'm going to create another engineering drawing. So GA drawings here. I'm going to say this time I'd like to have an elevation drawing. So we'll say create the drawings. And what I'm going to do is I'm going to have a 3D view of the model. I'm going to have elevation on grid line G. And let's say an elevation on grid line 4. So that's 3 views. And we say, okay, create that drawing. And again, it creates those. There we are. You can see then what I've got is I've got different sections through, plans and elevations. So I'll just change the scale of these. I'll click on this and say that's a scale, let's say 1 to 200. That's a scale of 1 to 100. And this one here is a scale of 1 to 100 as well. So pick this up. So you can type in what you're looking for, like so, not 1000, there we go. And we'll say arrange those drawing views. They are now placed in there. And again, you can look at these pieces, add the marks you're looking for. As well will keep itself fully updated from any changes to the model. Again, look, it's just a drawing as well. You can do what you want with it. So you can alter it. You can add level markers. So we can say what's the mark, the level to the underneath of here. It's minus 500. What's the level to the top of here? 5 meters. So again, all that information is read from the model. I can even say, okay, let me create a detail view. So we'll say create a detail view. Let me choose something. In fact, I'll do this one here. So we'll say here, create a detail view of that joint. Put it over here. Click on that. Make that a scale, let's say 1 to 10. And that's a blow-up detail look of that, like so. Right, so that's how we look at an existing model, and that's how we create a model from nothing. But what I'm going to do now is I'm going to say, okay, let me pass this out now down to the CNC machine. First of all, to steel projects, which will do the workshop management. So within Tekla then, we say export that out. This is a special export, a really sophisticated export that takes care of everything. We run this, click on that. It launches up the application, and then we say, okay, the whole model, export that out. And then what it does, it creates all the data, goes straight down to the next software, which you're going to see, which is the next part of the process. Okay, so that's now been done. So you imagine now, I'm going to pass this to my colleague, and he will take it the next step. So now I believe it's coffee break. I've got another presentation later on, so I'll see you later on as well. So thank you.